Hey Year 12, today what we're doing is looking at integration involving exponential functions. So we're going to establish and use the formula the integral of e to the x dx is e to the x plus c, and the integral of e to the ax plus b dx is 1 over a e to the ax plus b plus our c. So we can write the antiderivative of ex as an integral. So the integral of e to the x is the integral of e to the x dx equals e to the x plus c, and that is not on your reference sheet. The integral of a to the x dx is equal to 1 over ln a of a to the x plus c. And then we have our integral of e to the ax plus b dx is equal to 1 over a e to the ax plus b plus our c. So on our reference sheet, in terms of exponential functions, we have the integral of f dash x of e to the x dx of e to the fx, e to the fx dx is equal to e to the fx plus c. We also have the integral of f dash x of a to the fx dx is equal to a to the fx over ln a plus c are our two formulas that we have in terms of exponential functions in our integral calculus list. Okay, our first one here, we want to evaluate the integral of 0 to 1 of 5e to the x dx. So what this is equal to is we just leave our 5 out the front and we integrate e to the x. So the integral of e to the x is e to the x, the same as when we differentiate, and we want to substitute in our values of 1 and 0. So we'll have 5 lots of e to the x minus our 5 lots of e to our first x, which is 1, minus e to the second x, which is 0. So what we have here is we have 5 lots of e to the 1 is just e, minus e to the 0 is 1. Okay, our next example here, we want to find the integral of 4 to the power of x. Oh, I'm missing my dx there. I'll quickly add that on. With respect to x, so we need our dx. So what we need to do for this one is we need to include our, we need to look at our formula for starters. So for our formula, we have the integral of f dash x of a to the fx dx is equal to a to the fx over ln a plus c. So we have our a is 4 here. So this is where we have a equals 4 and our fx is equal to x. So our f dash x is just equal to 1. So we don't need to worry about this right now. We have the integral of 4 to the x dx is equal to our 4 to the x over ln of our a, which is 4, plus our c. Alrighty, example 2, we want to find the integral of 1 to 2 of 5e to the 3x. So what we have to do here is, again, we leave our 5 out the front and we look at our e to the power of 3x. We bring our derivative down the front, so we'll have 1 over 3 e to the 3x when we are differentiating this, and we substitute in our, when we're integrating this, and we'll substitute in our 1 and our 2. This is then equal to 5 over 3 of e to the power of 3x, and we need to substitute in our 2 and our 1. So let's do that. 5 over 3 lots of e to the 3 lots of 2 minus our e to the 3 lots of 1 is equal to 5 over 3 lots of e to the 6 minus e to the 3. We can then factorize, e to the 3. We can then factorize out an e to the 3, so we'll have 5 over 3 e to the 3, and we have left over e to the 2 e to the 3. We have 3 lots of e's worth, minus 1 left over. So that is our final answer there. And lucky last, we have the integral of e to the 2x minus e to the negative x dx. So when we integrate, we're integrating each thing separately. So the integral of e to the 2x is equal to 1 over 2 e to the 2x minus our integral of e to the negative x is 1 over negative 1 e to the negative x, and we need to plus our c because it is indefinite. And then this simplifies to be e to the 2x over 2. These two minuses turn into a plus, e to the negative x plus c. We can rewrite e to the negative x as 1 over e to the x. So our final answer is e to the 2x on 2 plus 1 over e to the x plus c. For this exercise, you are completing 706, question 1 to 3 ACE, question 4 to question 7.